So this is going to be a chapter 3-4 review about triangle congruencies and stuff like that. Okay, so sorry that's blurry. Use the slopes to determine whether the opposite sides of a quadrilateral ABCD are parallel. Then use the slopes to determine if consecutive sides of the quadrilateral ABCD are perpendicular. Then write an equation that passes through two lines. Okay, so let's graph these first. So I have zero, 2 is going to be right here, so that's A. 3, 4, so I go over 3, up 4, that's B. 2, 7, 1, 2, 3, 4, 5 is C, and negative 1, 5 is D. Okay, so here is my parallelogram. So I need to see if the opposite sides are parallel. So if I'm looking at this, here's a side and here's a side. So let's check to see if those are parallel. So DC and AB. Okay, so let's find the slopes and see if they're the same. So if I do AB first, I'm going to do 4 minus 2 over 3 minus 0. 4 minus 2 is 2, 3 minus 0 is 3. Now let's check to see if CD is the same. So 5 minus 7 over negative 1 minus 2. 5 minus 7 is negative 2. Negative 1 minus 2 is negative 3. Two negatives make a positive. Okay, so we know AB and CD are parallel. So now let's check my other sides. So let's check AD and BC. So AD, the slope, so these two, it is 5 minus 2 over negative 1 minus 0. 5 minus 2 is 3. Negative 1 minus 0 is negative 1. So negative 3. And then we have to also check BC to see if they're the same. Okay, so then that's 7 minus 4 over 2 minus 3. 7 minus 4 is 3. 2 minus 3 is negative 1, so negative 3. Okay, so we know both of the opposite sides are parallel. Okay, so now I'm going to erase all this because the next portion is whether we have some perpendicular lines. Okay, so it says the consecutive sides of the quadrilateral being perpendicular. Okay, so now I'm going to be talking about this line and this line if they're perpendicular, because if they extended, they would run into each other like perpendicular lines. Okay, so we have BC and AB. Oops. So BC and AB, we're finding the slopes of those to see if they're opposite reciprocals. Remember, perpendicular lines, opposite reciprocals. So let's do AB first. So we have 4 minus 2 over 3 minus 0. 4 minus 2 is 2. 3 minus 0 is 3. Okay, and then my other one was BC. So BC is 7 minus 4 over 2 minus 3. 7 minus 4 is 3. 2 minus 3 is negative 1. 7 minus 4, 2 minus 3. Okay, which is negative 3. Okay, so we know that those lines are not perpendicular because they're not opposite reciprocals. Remember, opposite, one has to be positive, one has to be negative. Reciprocal, one has to be one way and the other way has to be flipped. Okay, so let's try our others that are consecutive sides. So I'm going to switch colors. So now let's try this one and this one. So that one is C and D, so let's do that one first. So we have 5 minus 7 over negative 1 minus 2. 5 minus 7 is negative 2. Negative 1 minus 2 is negative 3. So we have 2/3. And then my other one is AD. So 5 minus 2 over negative 1 minus 0. 5 minus 2 is 3. Negative 1 minus 0 is negative 1, so negative 3. Okay, so we could see that those are also not perpendicular because they are not the same. Or not the same, the opposite reciprocals of each other, sorry. So let's try another one. We could do CD and BC this time. I'm going to erase all this. Okay, so CD, 5 minus 7 over negative 1 minus 2. So negative 2 over negative 3 is 2/3. And then also BC, so 7 minus 4 over 2 minus 3. Okay, so you can see that those are also not opposite reciprocals of each other. Okay, and then there's another set that you can do. You could do this one and this one. Okay, so use the slopes to determine whether the opposite sides, so we're going to do the same thing again. So let's graph them. So A is negative 3, 1. B is 1, negative 2. C is 0, negative 3. And D is negative 4, 0. Oops. Okay. So we're doing parallel and perpendicular, so let's do parallel first. So we're doing AD and CB first. So AD, we have 0 minus 1 over negative 4 minus negative 3. So negative 1 over negative 1, so positive 1. And then my other side was CB. So negative 3 minus negative 2 over 0 minus 1. So negative 1 over negative 1, so 1. Okay, so those two sides are parallel. Now let's do our other two sides. So we're going to change colors here. So I have DC. So DC, 0 minus negative 3 over negative 4 minus 0. So 3 over negative 4. And then my other side is AB. So AB, negative 2 minus 1 over 1 minus negative 3. Negative 1 over 4. Okay, so those two sides are not parallel. Okay, now we got to see it perpendicular. So I'm going to erase all of this. Switch colors. Okay, so let's do AB and BC. So AB, we got negative 2 minus 1 over 1 minus negative 3. So we got negative 3 over 4. And so BC or CB, we got negative 3 minus negative 2 over 0 minus 1. So negative 1 over negative 1, so 1. So you can see that those aren't perpendicular. Let's do another one. Let's do DA and AB. So DA, we got 0 minus 1 over negative 4 minus negative 3. Negative 1 over negative 1, so 1. And then my other one was BA. So negative 2 minus 1 over 1 minus negative 3. Negative 3 over 4. Okay, they're not opposite reciprocals of each other, so they're not perpendicular. So then my next side, I could do this side and this side. So you check to see if those are perpendicular. And then you would have to check this side and this side to see if those are perpendicular. So you have to check all of the sides that are consecutive to make them perpendicular. Okay, my next one. So I need to solve for x, y, and z. So all angles should add up to be 180 degrees in a triangle, so we know that piece of information. This creates a straight line, so we know that that's 70 degrees. So we can take 63 plus 70 plus x, and it should equal 180 degrees. 133 plus x equals 180. We subtract 133 from 180, so x equals 47 degrees. So we know that that is 47 degrees. Y is a vertical angle of 63, so y is 63 degrees. So now we have 63 plus 85 plus z, because they should all equal 180. 63 plus 85 is 148. take away 148 from 180, so Z equals 32 degrees. Okay, 72, we could take 72 plus 86 to get that missing angle, so we'll call it X, and they should all equal 180. 72 plus 86 is 158. Subtract 158 from 180, so we have the measure of angle 3 being 22 degrees. Remember, label it degrees. That means the measure of angle 4 is also 22 degrees because they're vertical angles. So then we could take 22 plus 70 plus, let's call that Y because we don't know what it is, set it equal to 180. 22 plus 70 is 92. Subtract 92 from 180 to find the measure of angle 5 to be 88 degrees. Okay, so all angles in a triangle should add up to be 180 degrees. We know that that little square there means it's 90 degrees, so I'm going to take 3x plus 90 plus 4x minus 1 and set it equal to 180. So 3x plus 4x is 7x, 90 plus 90 minus 1 is 89. Subtract 89 from both sides, so I'll get 91, divide by 7, x should equal 13. Okay, but I want to find the missing angle measure, so we got to plug x back in. So this one is 13 times 3 to get 39 degrees. This one is 4 times 13 minus 1, so 51 degrees. Okay, let's add them all up. X plus 6x plus 10 plus x plus 2, set it equal to 180. X plus 6x plus x is 8x. 10 plus 2 is 12. Subtract 12. 180 minus 12 is 168. Divide by 8. X should equal 21. Let's find our missing angle measures. So this is 21 degrees. This is 21 plus 2, so 23 degrees. This is 6 times 21 plus 10. 6 times 21 is 126 plus 10, so that should be 136 degrees. Deduce the angle measures. Okay. So we can see that A, if we have these being parallel lines, A is corresponding to that 90 degree angle. So the measure of angle A is 90 degrees. So if that's 90, we can take 90 plus 22 and subtract it from 180 to get the measure of angle B. So 90 plus 22 is 112. 180 minus 112 is 68, so B is 68 degrees. Angle C and angle B create a 180 degree angle. So I could take 180 minus 68 to find the measure of angle C. So 180 minus 68 is 112 degrees. Okay, and we have these parallel lines again. So C and D are alternate interior angles, which mean they are the same. So measure of angle D is 112 degrees. Okay, D and G are same side interior angles. Let's do E though. So measure of angle E. D and E create a straight line, so I could take 180 minus 112 to get E, so 68 degrees. So we know E is 68 degrees, and we know those sides are the same. That means these two angles here should be the same. So I'm going to take 180 minus 68 to figure out what my two total angles are going to be. So right now I have 112 degrees left. But if those two angles are the same, I need to divide it by 2 to figure out what each angle is. So 112 divided by 2 is 56. So F is 56 degrees. Which means this is 56 degrees. G and that one create a 180 degree angle because they create a straight line. So I'm going to take 180 minus 56 to get G, to get 124 degrees. G and H are alternate interior angles because they are on the same transversal and they're in between my parallel lines. alternate interior angles are the exact same, so G and H are both 124 degrees. Okay, proof. So I always start with my given, so I'm just going to draw an arrow to save time. And the reasoning is always given. Okay, so C is the midpoint of AE and BD. So what can we prove? Well, if it's the midpoint, that means it sits in the middle of those two lines. So it sits in the middle of AE, so that means these should be congruent. So AC is congruent to CE by definition of a midpoint, because a midpoint sits in the middle, so it cuts it in half. So I'm going to say MP for midpoint, which also means that if it's the midpoint of AE and BD, that means BC and CD are also the same. By the definition of a midpoint. 4, we have some vertical angles. Okay, so I'm going to be specific on which angles I'm talking about. So angle ACB, C has to be in the middle because it's my vertex, is congruent to angle ECD by vertical angles, because vertical angles are always congruent. Okay, so now I can say we have a side, an angle, and a side written in order. So SAS, okay, because we have 3 sets of things that are congruent, I can automatically say my triangles are congruent. So triangle ACB is what I was is congruent to triangle ECD by side, angle, side.